Hey everyone, welcome back to NetTalk, where we break down networking concepts in a way that's clear and easy to understand. If you're new to IT or studying for your CompTIA exams, you're in the right place. Today, we're going deep into one of the most important topics in networking, the OSI model. It might sound technical, but I promise, after this video, you'll understand it like a pro. The OSI, Open Systems Interconnection, model is a conceptual framework that standardizes the functions of a networking or telecommunication system into 7 distinct layers. Each layer serves a specific purpose and communicates with the layers directly above and below it, enabling seamless data transmission across diverse systems and devices. Starting from the bottom, the physical layer handles the actual transmission of raw binary data over physical media. The data link layer ensures reliable data transfer between devices on the same network using hardware addressing. The network layer determines the best path for data across networks through logical addressing and routing. The transport layer provides end-to-end communication control, ensuring data is delivered accurately and in order. The session layer manages and maintains sessions between applications. The presentation layer translates data formats, handles encryption, decryption, and ensures data compatibility between systems. At the top, the application layer interacts directly with user applications, enabling network services such as web browsing, email, and file transfers. Together, these layers facilitate interoperability and efficient communication in complex network environments. Here are the 7 layers of the OSI model. We usually explain them from the bottom up, starting from the physical cables to the actual software or app you're using. Let's break down each one with real-world examples. The physical layer, Layer 1, of the OSI model is responsible for sending and receiving raw data bits over physical media, like cables or wireless signals. It defines how data is turned into signals that can travel through different types of media, such as copper cables, fiber optic cables, or even wireless signals like Wi-Fi. The physical layer has a few important jobs. It sets up the physical layout of the network, making sure the devices are connected correctly. It also defines the physical interface, like how cables are made or how antennas work for wireless signals. The physical layer handles signaling, which is how data is turned into electrical, light, or radio signals so it can travel. Devices that work at this layer include transceivers, which send and receive signals, repeaters, which boost weak signals, hubs, which connect multiple devices, and media converters, which change the type of signal. Layer 2. The data link layer is responsible for transferring data between devices on the same logical network segment. A segment is an area where all devices can communicate with each other using hardware addresses, regardless of the physical media they share. It's important to note that a logical segment can include multiple physical segments, and this is known as a logical topology. In most local networks, devices aren't directly connected using point-to-point or mesh connections. Instead, each device connects to a central node, like a switch or a wireless access point, AP. The central node helps route the data between devices. To make this possible, each device on the network is assigned a data link layer address, also known as a hardware address or MAC address. One of the main jobs of the data link layer is to organize the raw data from the physical layer into frames. These frames are structured units that contain the data, called a network layer packet, and additional control information, such as the source and destination MAC addresses and an error check to ensure the frame was received correctly. Devices that work at the data link layer include Network Interface Card, NIC. The NIC connects a device to the network and helps it send and receive frames. Bridge. A bridge connects different physical network segments and helps keep performance efficient by reducing network congestion. Switch. A more advanced form of a bridge, switches connect many devices more efficiently, managing data traffic between them. Wireless Access Point, AP. An AP connects wireless devices to a network, bridging communication between wireless and wired devices. Layer 3. The network layer is responsible for moving data between different networks, also known as an internetwork. Unlike the data link layer, which handles data transfer within a single network segment using hardware addresses, the network layer uses logical network addresses, like IP addresses, to route data across multiple networks. These networks may be different from one another, using different physical media or data link protocols, which is called heterogeneity. The key device at this layer is the router. Routers determine the best path for data to travel from its source to its destination across the internetwork. The data is packaged into packets or datagrams, each with a destination network address. The packet moves from router to router, or hop to hop, until it reaches the correct network. Once the packet reaches the destination network, it is delivered to the target device using the hardware address, MAC address. The network layer also plays a role in traffic filtering. Routers and firewalls at this layer can enforce security by using an access control list, ACL. An ACL is a list that defines which addresses or types of traffic are allowed or blocked. Layer 4. The transport layer is where the content of the data packets becomes important. Unlike the first three layers, which mainly focus on moving data between nodes and networks, the transport layer ensures that the data is delivered correctly to the right application on the receiving host. This layer handles the communication between different hosts on a network, ensuring that data is properly directed to the correct service, like a web server or email server. One of the transport layer's key functions is to assign a port number to each type of network application. For example, web traffic uses port 80, HTTP, while email traffic uses port 25, SMTP. This helps to identify which application should handle the data. When data is sent from a host, it is divided into smaller units called segments at the transport layer. Each segment is tagged with a port number and is then passed to the network layer for delivery. Even if multiple applications, like HTTP and email, are sending data at the same time, the transport layer uses port numbers and network addresses to manage these different streams of data, allowing them to share the same network link. At the receiving host, the segments are demultiplexed, which means the data is sorted and sent to the right application based on its port number. The transport layer can also ensure reliable data delivery by resending any lost or damaged packets if necessary. Devices that work at the transport layer include multi-layer switches, which often work as load balancers, and security appliances like advanced firewalls and intrusion detection systems, IDS. Layer 5. The session layer is responsible for managing the communication sessions between devices. A session is essentially a connection between two devices or applications that enables them to communicate with each other over time. The session layer handles tasks such as starting, maintaining, and ending these sessions. For example, when you're making a video call or logging into a website, the session layer ensures that the connection is properly established, remains active while you're interacting, and is safely closed when you're done. It organizes the flow of data between applications and makes sure that communication can resume smoothly, even if the connection is temporarily interrupted. Layer 6. The presentation layer is responsible for translating data so that it can be understood by both the sending and receiving devices. It ensures that the format of the data is readable on both ends of the communication. The presentation layer handles data encoding, compression, and encryption, making sure that any information sent can be interpreted correctly. For example, when data is encrypted using SSL for secure communication over the internet, the presentation layer ensures that the data is securely formatted and readable only by the authorized parties. Similarly, when you watch an MP4 video, the presentation layer may compress the video data so that it can be transmitted efficiently and then decompressed at the receiving end so you can view it correctly. The application layer, Layer 7, is at the top of the OSI stack. An application layer protocol doesn't encapsulate any other protocols or provide services to any protocol. Application layer protocols provide an interface for software programs on network hosts that have established a communications channel through the lower-level protocols to exchange data. More widely, upper layer protocols provide most of the services that make a network useful, rather than just functional, including web browsing, email and communications, directory lookup, remote printing, and database services. Here's a fun way to remember all 7 layers. Please do not throw sausage pizza away. One word for each layer, from the bottom to the top. So why does this matter? Because when something goes wrong, like slow internet or connection errors, understanding what layer handles what helps you pinpoint the issue. It's also a major topic in the CompTIA A+ and Network Plus exams. Coming up next on NetTalk, we'll explore IP addressing, the key to how devices actually locate and communicate with one another. That'll make everything we talked about today even clearer. Thanks so much for watching. If this helped you understand the OSI model better, give it a like, subscribe, and let me know in the comments which layer makes the most sense or which one still confuses you. This is NetTalk, and I'll catch you in the next episode.